Right, so looking at example 3.1, the main idea is if we go from a more ordered state to a less ordered state, we should see a corresponding increase in our entropy, which we use the symbol delta S to indicate a change in the entropy, and of course larger than zero meaning it increased. Or if we go from a less ordered state to a more ordered state, to mean that delta S was less than zero. Okay, so what do we mean by more ordered or less ordered? So essentially looking at the examples will give a better idea of that. So our crystallization of a salt from solution. So what we have here is we have some vessel with water or whatever, some solution in it, and we have some ions, drifting in here, but they're basically free to move in whichever direction they feel free to move in. But the system changes to crystallization of a salt. So in other words, it moves to a salt structure. So let's say that's, for example, sodium chloride. And sodium chloride is a very rigid cubic structure which looks something like this. It's three-dimensional, so it has this. There's chlorines there, chlorine there, chlorine there, and it's like I said, extends in 3 dimensions. So I think I actually have an extra chlorine. 1, 2, 3, 4, 5, 6. No, it's the right amount. It's actually just on the wrong side. It shouldn't be there. It should be there. Anyway, and this extends all the ways that you can think of, and these go on. So of course, this is what we say we'll call more ordered than this, which is less ordered, because you agree. In this case, we have ions that can basically drift wherever they want, and in this case, we have ions that are in a solid crystal lattice. So in other words, they can't really move to wherever they would like to. So we have a situation where our delta S is then less than zero, because we go from a less ordered state to a more ordered state. Okay, same idea here again. So let's imagine two vessels again, or two containers of the same size. In the one we have the gas, my apologies, we have the gas particles, whatever they are, and in the next one they've condensed to a liquid. So in which case would you say we have the more ordered state, and which case would you say we have the less ordered state? Well, of course, the gas is free to move in whichever direction these molecules, atoms, ions, what please. So in other words, there's random movement in any direction that you can think of here. So again, we have a less ordered state here and a more ordered state here, even though a liquid is also disordered, but it's disordered compared to a solid again, for example. So in other words, again, we have delta S is less than zero, because we're comparing these things to one another, and relatively the change in delta S will be less than zero. So entropy is the measure of disorder. So in other words, the change in entropy is the measure of disorderedness. So are we going from a state which is more or less disordered than the previous one? Basically, is the question, and that's what this symbol or inequality is telling us. So returning now, basically, we're chemists, so trying to come into some chemical reactions. If we go from something which is a solid, so in other words, some solid crystal lattice again, something that's connected in 3 dimensions, very solid and rigid, to something that's also very solid and rigid, again, still a solid, but now there's also a gas. So in other words, something that's free to move in whichever direction it wants to. So which state is more ordered and less ordered? Of course, this right-hand side, because of the gas. The gas is less ordered. So we go from a more ordered state to a less ordered state. So we see there should be an increase with the entropy because we have an increase in the disorder. Right, so in other words, an associated increase in the entropy, because entropy is a measurement of the disorder in a system. Right, so in other words, its change measures the increase or decrease in this order of the change. Right, another example, gas, solid, solid. So what do we have? A bunch of arrows plus something that's ordered gives something that's ordered. So in other words, we have something that's free to move and we have something that's not free to move. So we see a decrease in the disorder. And then finally, we basically have something which is the same as we saw in example A, or 3.1a, because again we have some ions in solution. So we have our silver ions and we have our chlorine ions, and they're free to move however they please in this solution, but then they crystallize to form the solid. So in other words, I think silver chloride actually has a very interesting structure, if I'm not mistaken. Okay, it doesn't really matter how it looks, but anyway, point is you'll get a more ordered structure. So in other words, we go from less ordered to more ordered, and again that's why we expect delta S to be less than 0, or the change in entropy to be less than 0, because we're going from less ordered to more ordered. Right, so that's example 3.1. I hope it gives some more insights into what was explained in the notes, and also these drawing of these things help in your thermodynamics, even for your processes. I mean, thinking about, does a gas expand or whatever, will later on help you understand whether or not do you expect your entropy to increase or decrease, your enthalpy, your pressure, that kind of thing. These little sketches are very handy, so do it, start doing it, it's always useful. Right.